Welcome back to the series of insights into meshing. So this is going to be the first detailed video of the insights of meshing. The first video will concern about why the meshing is required, and we'll also take into account the physics point of view and the mathematics point of view. So let's start into the tutorial. Why the meshing is required from the physics point of view. Let's start with it. So we have thoroughly developed physics, and the developed physics is generally what we have known from the Newtonian physics. There are other different kinds of physics also developed, and all the developed physics have governing equations in them. These governing equations are applied to a domain. So what a domain means? The domain means some boundary inside which you have some interest, the body of interest. So, and on the governing equations are applied to the body or the domain, and we input the independent parameters, and this input of independent parameters will give us a result on the interested dependent variables. So the first point you should make a note of is I have mindfully selected independent as parameters and the variables are dependent. We cannot change them, that the variables cannot be independent. The independent variables actually are not called as parameters. So parameters are by default variables, but variables cannot vary by themselves. Variables are dependent on parameters. So whatever user changes or the change of value which comes from the user end, they are the independent thing, and they are called as parameters. And whatever the result comes, which the results are dependent on the input parameters, they are called the dependent variables. So they are not interchangeable terms. So you should be uh, thorough with this. Then the second point of interest is what what are the independent parameters generally. So from a solid point of view, if we have a solid body and if we are going to compress it from both ends, let's say we are going to compress it, its body is under compression. So in this case, what are the independent parameters or the parameters or the values which user has to provide? The user will provide the dimensions of the geometry or the body. Then it will also provide the material properties, such as it is a solid of steel, aluminum, gold, titanium, carbon, alloys, different kind of alloys are also available. It's a fluid body, etc. It's a polymer. So there are different choice available to us. So material properties comes into independent parameters strictly. They cannot be dependent variables in any case. Then the next point will be, if we are applying some force, if we are applying some deformations, if we are applying some velocity to it, if we are applying some acceleration. So these are the different independent parameters we put in. If it was a fluid, then the flow parameters are available, fluid properties are there. So it's viscosity, density, different kinds of properties related to fluid are there, which will come into the bucket of independent parameters. Then if we are going to compress it, it may deform in some other directions. So since it is going to change or reduce its length in the axial direction, in the transverse direction it will bulge out. So the result of interest will be, if there is a deformation, how much is the total deformation. If there are directional deformations available, we can check the specific direction deformation, such as in y direction, z direction, etc. Then we can have stress, we can have strains. In stress and strains also, we have principal strain, Mises strains, and we have directional strains, Tresca criteria, invariants of strain, shear stress. So there are different kinds of things. So there are a lot of different sets of results we can have. First, you should be mindful of what kind of results you are looking for. You should not be just for fun looking for different kinds of results and plots. You should first think of what different things or results you want to check, and then select that. Yes, I want to see the stress distribution, I want to see the strain, deformation, and if there are endurance properties involved, there is a fatigue, then there are results related to fatigue, that there is a stress after 10 cycles, the stress after 100 cycles, etc. Then if there is friction involved, there are contacts involved, then contact stress can come up. So there are different sets of dependent variables also there. But what's the problem now? We have the governing equations, or which are called as the Newton's three laws, or whatever, F is equal to ma. That is a very simple equation that it involves acceleration and force. or that involves velocity also independently, indirectly, and the change or the distance covered, or that's also involved indirectly. But what are the problems behind this? So these all governing equations which we have already, those are applicable to point mass only. The Newton's law are one of the example. So what are the point mass? Point mass are a representation of a complete extended body. So all the bodies which we have right now, a clock or a calculator, a pen, anything, those are extended bodies. And the point mass will be that all the mass of that body is concentrated at a single point. If we want to represent that extended body with a point mass, generally we find out the center of mass of the body and say that at the center of mass all the mass of the body is concentrated, and then we consider or assume that the extended body is a point mass. But that's the limitation, that all the governing equations are applicable to only point mass. And real life bodies are extended bodies, we already know, and on which we cannot easily apply those governing equations, or we can not simulate or model those as point mass in all situations. Because if we consider this circular clock or wristwatch as a point mass, all the mass will be at the center of this of this cylindrical wristwatch. In that case, the point mass is not going to be appropriately define that extended body. Or if I take some bottle kind of thing, then that bottle, the extended body geometry is such that the geometry, actual geometry, and the concentrated mass or that point mass or center of mass are not going to match easily. In that case, we cannot easily transform those extended bodies into point mass, and at that point of time the concept of massing is required. So in this case, when the bodies are not easily assumable into point mass from extended bodies, we need to split that extended body into smaller bodies. And that process of splitting is called as massing. So that's the end of this part. In the next video, we'll look at the maths part of it also and what actually is massing. So thank you.